Italy's recent pivot into unmanned systems and electronic warfare marks a deliberate effort to reframe its military posture in the Mediterranean and within NATO. For decades, Rome relied on sea power, amphibious projection, and integrated strike aircraft. Now, a different architecture is emerging, a layered combination of persistent sensors, uncrewed aerial systems, and electronic attack platforms. Together, these capabilities promise to increase domain awareness, complicate an adversary's targeting calculus, and provide asymmetrical options for a country constrained by budgets and geography. The Leonardo-Baykar Memorandum of Understanding is emblematic. Leonardo brings decades of expertise in sensors, avionics, and systems integration. Baykar offers combat-proven airframes and operational concepts refined in recent conflicts. The partnership is pragmatic. Italy can access tested tactical and medium-altitude capability while keeping control of critical subsystems and much of the supply chain. If managed intelligently, the collaboration could yield a competitively priced platform that is attractive domestically and on export markets, while allowing Italian industry to capture value in avionics, payloads, and systems integration. Complementing the unmanned layer, Italy's acquisition of an EA-37B electronic warfare aircraft represents a strategic force multiplier. Electronic warfare is no longer a niche enabler. It shapes the electromagnetic battle space and can determine operational tempo. The EA-37B provides long-range electronic attack, signals intelligence, and the ability to degrade or deny enemy sensors and communications. When paired with persistent sensor platforms, the effect is multiplying. Drones can find and fix targets, while EW assets blind adversary detection, creating windows for strike assets to operate with reduced risk. Operationally, the real advantage lies in integration. Uncrewed systems offer persistent eyes and, increasingly, precision strike options. EW platforms impose temporary denial of the adversary's sensors and networks. In a network-centric concept of operations, Italy can orchestrate missions that emphasize timeliness, distributed sensing, and low-risk attribution. This architecture is highly relevant to the Mediterranean's contested spaces, maritime choke points, littoral approaches, and hybrid threat environments, where state and non-state actors operate in close proximity, and where persistent ISR combined with electronic protection yields disproportionate strategic returns. For NATO, the implications are material. Italy's geographic position gives it a natural role as a southern hub for surveillance and electronic protection. As Rome develops indigenous or allied unmanned and EW capability, NATO benefits from enhanced situational awareness and electronic resilience across the central Mediterranean, a theater of rising strategic competition, irregular migration flows, and proliferating drone use. Italy's posture could complement Eastern NATO hubs by providing a southern node focused on maritime domain awareness, counter-swarm defense, and spectrum dominance. Yet the path is not free of pitfalls. Domestic politics and fiscal limits are the foremost constraint. Italy's public finances are tightly contested, and defense investments must compete with social spending and infrastructure ambitions. Hence, the political creativity around labeling dual-use projects as defense-relevant. To sustain modernization, Italian planners need to demonstrate clear returns on investment, measurable improvements in operational capability, credible export prospects, and tangible force-multiplying effects for alliance operations. Technical integration also presents a significant challenge. Unmanned systems from multiple suppliers must be fused into legacy command and control frameworks. EW aircraft require secure, resilient data links and deconfliction protocols to avoid fratricide and maintain mission integrity. Building an information backbone that is resilient against cyber attacks and capable of low-latency sensor-to-shooter cycles demands sustained investment in networks, cryptography, and skilled personnel. Hardware procurement is only part of the bill. Software, training, doctrine, and sustainment account for an equal share of long-term success. Operational and training reforms are necessary. Combined UAV-EW operations are conceptually powerful, but require new doctrine and realistic joint training. Italy should institutionalize exercises that test sensor fusion, contested communications, and coalition command arrangements in littoral scenarios. Doing so will reveal integration gaps, refine tactics, and provide a feedback loop for industry. Equally important is developing modular, open architectures to ease integration and encourage multinational interoperability, especially if Italy hopes to export systems or field coalition solutions. Diplomacy matters as much as technology. The Baykar link accelerates capability but introduces political risk if supplier states' policies diverge from NATO consensus. Rome must anchor technology partnerships through multilateral frameworks, EU research programs, NATO industrial initiatives, and bilateral co-production agreements to reduce exposure to abrupt policy shifts. Diversifying suppliers and deepening interoperability with trusted partners will mitigate strategic risk while preserving the benefits of rapid capability absorption. Real-world scenarios make the promise tangible. In a high-intensity contest, EA-37B sorties could suppress area sensors, allowing unmanned platforms to approach contested littoral regions undetected and enable precision fires. In a hybrid campaign, Italian UAVs could provide continuous monitoring of maritime approaches, feeding actionable intelligence to coalition commanders, while EW assets degrade adversary command and control. In peacetime, these capabilities enhance deterrence and lower the political cost of intervention by enabling precise, low-risk contributions to coalition operations and humanitarian missions alike. An export and industrial dimension also exists. If Leonardo and partners can deliver an affordable, combat-proven unmanned system integrated with Italian avionics and payloads, buyers in Europe, North Africa, and the Middle East will take notice. Exports would strengthen Italy's defense industrial base, create economies of scale, and increase interoperability incentives. Export controls and geopolitical sensitivities will require careful policy calibration, but the potential economic and strategic dividends are significant. Looking to 2035, a plausible positive trajectory positions Italy as a pivotal middle power in unmanned and electronic warfare. A fleet of medium-altitude surveillance and strike UAVs, integrated with a limited number of strategic EW aircraft and a distributed network of hardened sensors, would enable Rome to project influence across the Mediterranean with lower cost and political friction than traditional heavy platforms. The critical requirements are straightforward. A coherent national program linking industry, doctrine, and export strategy, defensible budgeting that survives domestic scrutiny, and commitments to interoperability and supply chain resilience. Execution will be decisive. If Rome aligns doctrine, industry, budgeting, and multilateral partnerships, Italy can convert a period of fiscal constraint into a strategic advantage, fielding a compact, resilient, technologically advanced force optimized for 21st century conflict. If it fails to integrate systems, sustain funding, and manage political risk, investments will fragment, and the nation's ability to influence outcomes in its maritime neighborhood will remain modest. The strategic choice is clear. Adopt integration and partnership as force multipliers, and Italy can become the Mediterranean's quiet center of unmanned and electronic warfare expertise.